Today I'm on a VCN 600 machine and I'm going to demonstrate how to generate the M16 parameter. So the M16 parameter is the small adjustment parameter for adjusting your home axis position. So I've got a small model here now and it's going to demonstrate. This is our table, our ball screw, our servo motor, and we have an encoder. Now I've separated the encoder so we can see how this value is generated. So from this model, I'm going to move this back to my home position. I'm going to read my nameplate, and my stroke is 600 millimeters. So half of my stroke, that's 300 millimeters. So I'm going to move it to 300 millimeters. Now it's okay. If you don't know the actual stroke, you're going to move it to your T-slot, which could be in the center of your table. Or if you don't have a table, it could be to your spindle, the center of your spindle. Any datum on the machine to which you can use, so you can calculate the center stroke of your linear guide rail. So I've used my T-slot as the center. When I've got that to the center, I'm going to transfer this over to the machine. So now on the machine, I've got the clock. This is set up now. So when I turn this, I have 0 and I have 0. So we have center. This is on our T-slot. We have no value in our M16 parameter. Just to demonstrate that, parameter, it's a machine parameter, feed velocity, and we can see here in our y-axis we have no value. So how do we get this value? So for example, if you change your ball screw, you change your motor and encoder, it's all been disconnected, we don't know our parameter here. So I've taken this out. So how that is generated, go back to our position. So as you can see, we've clocked up our T-slot, so we know our datum is our T-slot. So that's 300 millimeters from our T-slot, which is here, back to our home position here. Using our WPC or workpiece coordinates, I can press this and I can zero these out. Now, times 1000 on the hand wheel in y-axis, I can move this to 300 millimeters. This one, I'm just going to move the clock out of the way. And I'm going to turn this to 300 millimeters. For my home position, just by using the datum of our T-slot. Now it's important to do this because we have no parameter in there, so it's searching for a parameter, so it's searching for a home position. Now there is no soft limits with this. If you change our parameter, we've opened it up and it's in like a home teaching mode, so you can crash this machine, so it's important to take this slowly. This is our 300 millimeters, so from the center of the T-slot to our home position is 300 millimeters. So for our T-slot back home, we can confirm that by our arrow keys. You can see those are lined up. Well, we want to know, where does this M16 value come from? So we go to Diagnose, Version, Servo Monitor, page 8. So when we see our grid space going along, this is our ball screw pitch, or one full revolution of our ball screw, 12 millimeters. And we can also see our grid. Now our grid represents the encoder feedback. So when we come back to our model, I've clocked up my table, center of the T-slot. I've zeroed off my WPC and I've wound this back to 300 millimeters. So from the center, 300 millimeters. So I'm going to teach this as my home position. But where does that value come from? Where does this value? So we can see here, we have the servo motor, the encoder. The encoder feedback, every full revolution is 12 millimeters. So it just so happens where this 300 millimeters stops, it will stop 1, 2, 3, 4, 5, 6, 7, 8. So it stopped at 80035, and this is our feedback from our encoder, and we can see the feedback on our servo monitor, page 8 in our grid. So we can see one full revolution, 12 millimeters, then for our 300 millimeters, then it's come round and it's stopped at 80035. This is the value we place in M16. So in order to do that, we can either write this down on a piece of paper, or we can use our calculator. We can put in 80037. If we close that down, go back to our param, it's a machine parameter, M parameter. In our Y there, so we just tapped on that. I can tap in 80, the parameter value, which I wrote down, or I can bring up my calculator and it's actually stored that in there. So instead of doing clear or all clear, if I press input, you can see place my value in there, which is my M16 parameter on my page 8 of my servo monitor. So now that's gone in. That's my parameter. Normal process now is to go to diagnose, version, servo monitor, page 8, times 1000, y-axis. I need to come down to 0, into the next grid, press home, Y plus, back up to that value which we read from our encoder, and our machine has gone back to home. Now if, for example, you've changed your ball screw, change your motor, but the encoder feedback happened to land round about 0. You don't want it near 0. Ideally, you want it half your grid. So you'd want it around about 6 in a perfect world. So what do you do? How can you change that? The only way you're going to change that is because you've changed your motor, you change your ball screw, you can undo the coupling and turn this motor or your ball screw half a turn. So when you do your 0 again, because you dynamically you change that position by changing this coupling, it will stop around about 6 millimeters or half your encoder or your grid shift. Thank you very much.